gonna do is now I'm gonna conduct standard test method for sampling and testing concrete masonry units and related units. So what I have to do now is I have to mark each sample. We will count it C number 1. Here we go, and we can call this one C number 2. In the same time, we have got this one is gonna be counted as third one. Here we go. We have got received. We have got received weight, which is sample number 1. Sample number C1 is 23.40. Here we go. The next one. The next one is sample number C2. Its weight is about 24.65 kg. The next one is sample number C3. It's about 21.90 kg. Take its measurements in 2 locations opposite, which is here about an engineer is gonna write down 41 centimeters, 40.9 cm. And now I will take, you will record it as a 20.9, and the second location we have got 20.7, 0.5. Yep. And 19.7. Try the second sample dimension measurement. Yep, 40 centimeter. We have to take measuring dimension in 2 locations, opposite sides. This one is 39.9, which is gonna take place the same as we did in the first one. This one is gonna be 20.2. Yeah. And this one is 20.3 centimeters, as we have done it in 2 different opposite locations. Now what I have to perform is its height. Its height is about 21. In the second location, it's about 20.9. I'm performing the third specimen sample, which is 39.9, which is recorded, and length in the second location of the side is 40 centimeter. I'm gonna mark these 3 samples as sample C number 4. We need to immerse them in water for 24 till 28 hours. C number 5, and the last one is gonna be C6. Here you go. What I'm gonna do now is we will immerse them in water for 24 till 28 hours for absorption. What I have to do now is I need to immerse some sample number 4 in the water, and this is sample number 5. Here you go, and this is I've conducted immersion of specimen samples in water according to 8.2.2. Now what I'm going to do is indicate its temperature according to ASTM. Here we go, which is 18 Celsius. Now these 3 specimens is going to remain in water for 24 till 28 hours. After 24 till 28 hours, what we're going to do, we have to remove these specimens from curing tank, and we need to take its absorption procedure. What I will do now is I will introduce all equipments according to ASTM C140, which is a warming pot for keeping CMU blue, keeping mold. We have got spoon here, we have got a sieving brush, and we have got, and this is sieving brush. At the same time, we have got lubricant for keeping mold, and we have got 2 bearing plates, or we can call them distant space as well. High strength gypsum cement for keeping materials, and the warming pot, which is doing right now. That's enough. We will on the warming pot. In the same time, our temperature, heating temperature, is gonna be from 129 centigrade to 143. Now we are preparing specimen for keeping. We have to use an abrasive steam to remove the loose materials or protections from the surfaces of the specimen to be kept. As you can see, now we have removed the loose material from the specimen. As per section 7.2.2 capping using sulfur capping materials, we have to warm the capping plate before using it to slow the rate of hardening of the molten sulfur and the same time capping materials, and to permit the production to thin caps. Lightly oiled surface of the capping plate. As we are doing it now, we have to lubricate it. Then afterwards, we need to put this in the oven to get warm. The preheated oven, it's gonna remain. Keeping all this warm, what we need to do is we have to start our capping specimen. Sulfur, we need to pour them in the capping mold. Form a rectangular mold on the capping plate whose dimensions are approximately 13 mm greater than the overall dimension of the specimen. The mold must be sufficiently rigid not to move or reflect during the capping operation. Capped in the sulfur capping material without overflow. So therefore we need to place our capping mold on a flat surface. In the same time, for example, not to move. Yeah. Fill the mold to a depth of 160 mm with a hot sulfur compound. Bring the surface of the specimen to cap quickly into contact with the liquid, holding the specimen so that its axis is a right angle to the surface of the capping liquid, which is going to comply with the requirement of 7.4. As you can see, we are pouring some extra sulfur in it to fill the gaps. Yeah, as you can see, our specimen one side is over. What we need to do, we need to take this capping mold to the oven and we need to get it warm a little bit, and then afterwards we need to do the second side. As you can see, we have got preheated oven. We need to place our capping mold in there to get warm. Yeah, we need to. And now we are ready for the second side of specimen to be capped. As you can see, we have to grab our capping. Now we are doing the other side of specimen. So we have to pour our sulfur in the capping mold. In the same time, it should be in a very flat surface to give good result. Yeah, as you can see, we are pouring sulfur into the capping mold, and I have to put the sample in the capping mold. Yep, here we go. And now we need to put more sulfur in it for best result. Place the sample into the capping mold, as you can see now. Yeah, our capping mold is on a very flat surface, which is rigid as well. Yes, I have checked all sides of specimen, and there is no gap left. We are conducting and performing the second side of specimen. So as you can see, we need to pour some melted sulfur into the capping mold. Place the specimen in here. Yep. And we need to fill the gaps for best result. And we are capping the third specimen as well on the same way, same procedure. Capping procedure is over, and according to ASTM 140, we have to achieve its compressive strength according to 7.4, and it's going to take place right away. Position of specimens. Test specimens with the centroid of their bearing surfaces aligned vertically with the center of first separately seated steel bearing look at the testing machine. Except for special units intended or used with their cores in a horizontal direction. Test all hollow concrete masonry units with their cores in a vertical direction. As per section 7.1 test apparatus, the testing machine shall have an accuracy of plus minus 1.0% over the anticipated load range. The upper plate shall be a separately seated hardened metal block firmly attached at the center of the upper head of machine. The center of the sphere shall lie at the center of the surface held in its spherical, but shall be free to turn in any direction, and its parameter shall have at least 1.4 or 6.3 mm. Clearance from the heat to accommodate specimen whose bearing surface are not parallel. 4.3 speed of testing, we are applying load apply the load up to 1/2 of the expected minimum load at any convenient rate. After it has taken place, we need to uniform the rate of flight of moving except that the remaining load is applied in no less than 1 or more than 2 minutes. So here we go, as you can see. Yeah, here we go. We have applied load on 8. Yeah. As you can see, we have crushed the specimen in 10 for 3.3 kilonewton, which is done. We need to remove this specimen and crush the next one. As you can see, we are crushing the second specimen according to ASTM C140. As you can see, according to 7.4.3, speed of testing machine is going on, and we have applied glue already. So you'll see what's going on. As you can see, according to 8.3 procedure, we have got 8.3.1 saturation. As we have immersed the three specimens in water at temperature of 60 to 80 Fahrenheit, or we can say from 15.6 to 26.7 centigrade for 28 hours. Now what we need to do, we need to remove these samples from the water and allow them to drain from 60 for 60 to 5 seconds, and after that we need to wait this, and we will count that with a saturated weight. What we need to do, we will remove the visible surface water with damp cloth, and we will record the weight. We will count it as a saturated weight. Which is gonna take place right away. We need to dry this water. Here we go. Yep. This side. This is direct. Yep. Here we go. It's SSD, or saturated weight is 20 point C4. Here we go. It's 0.880 gram. Okay. This specimen or sample is done. Now what we need to do is we need to take sample number 5. Yes, its SSD weight is 23.070. Its SSD weight is 23.069 gram. Okay, this is the last one. Sample number 6. Its SSD weight is 22.847. 847. Here we go. It's absolutely done so far. Now we are doing weight and water of first specimen, and according to our scale, we have got 128, 14.1. As we have immersed the sample in the water,
C6.
so we need to write down 128 weight in water, 128, 3.9 gram. Okay, we will remove this specimen or sample from the water, which is done so far. As you saw, the specimen number 6, we are immersing in water sample number 5, which engineer conduct its sample number 5 in the water. So in the water, what I'm gonna do right now is I'm gonna take its reading. As we have immersed this sample number 5 in the water, I will take its weight in water and I will write it down. 1307. I will write it down. 1307. We are conducting the last sample, which is immersed in water. We are taking its weight. Its weight in water is 11913.7. I will write it down. 11913.3. What I have to do now is I have to do it according to 8.3.2 drying procedure. What we need to do is we need to dry all specimen in ventilated oven weighing at an interval of 2 hours, showing an increment of loss not greater than 0.2%. And I will in there for 24 hours after first in the oven. Now we are taking dry weight of sample number 6. And I want to write down its weight. Its weight is 22.45 and 0. And the next sample is sample number 5. As we did in sample number 6, we are taking its weight as well. This sample is sample number 5. Its dry weight is 22.72 and 4. Yep. After 2 hours interval, we need to take their dry weight again, which is gonna take place right now. Sample number 6. There we go. Yep, here we go. After 2 hours interval, its weight is again 22.450 with no deviation in differences. Second sample weight after interval of 2 hours. Okay, after 2 hours interval, its weight is again 22.72 and for, yeah, there is no deviation and differences between its intervals varying. Is sample number 4. What I'm gonna do now is I'm gonna take its dry weight is 20.260. This is sample number 4 and its weight is 20.257. We need to leave this sample for another interval of 2 hours after. Yep, there you go. You're taking sample number 4, dry weight, which is 20.257.